pump that functions as both a heater and an air conditioner falls under the 440.4b code for branch circuit calculations. The 440.4b code stipulates that the branch circuit for a split-system air conditioning unit must be sized to not less than 125% of the nameplate circuit ampacity. However, there's an exception for heat pumps that are rated at less than 100,000 British thermal units per hour. Because heat pumps are considered split-system air conditioning units, they generally are subject to the 125% rule. The exception for heat pumps rated at less than 100,000 British thermal units per hour permits sizing the branch circuit to the nameplate circuit ampacity without applying the 125% multiplier. To elaborate further, the National Electrical Code, or NEC, Section 440 covers air conditioning and refrigeration equipment. Within this, 440.4 addresses the ampacity of the conductors, and 440.4b specifically deals with multi-motor and combination load equipment. When calculating the branch circuit size for a heat pump, you need to consider the nameplate information. The nameplate provides crucial data, including the minimum circuit ampacity and the maximum overcurrent protective device size. The minimum circuit ampacity, often abbreviated as MCA, is the minimum current carrying capacity the branch circuit conductors must have. This value is determined by the manufacturer and takes into account the various components of the heat pump system, such as the compressor, fans, and controls. The maximum overcurrent protective device, or MOP, specifies the maximum size of the circuit breaker or fuse that can be used to protect the circuit. This rating is also provided by the manufacturer and should not be exceeded. Now let's delve into the 125% rule. According to the NEC, the branch circuit conductors supplying a hermetic refrigerant motor compressor must have an ampacity of not less than 125% of the motor compressor's rated load current. This is to account for the potential of the compressor to draw more current during starting and running conditions. However, as mentioned earlier, there's an exception for heat pumps rated at less than 100,000 British thermal units per hour. This exception recognizes that smaller heat pumps typically have lower starting and running currents, and therefore the 125% multiplier is not always necessary. When applying this exception, you can size the branch circuit conductors based on the nameplate circuit ampacity without adding the 25%. It's important to note that this exception only applies to heat pumps rated at less than 100,000 British thermal units per hour. For larger heat pumps, the 125% rule still applies. To determine whether a heat pump qualifies for this exception, check the unit's nameplate for its British thermal unit per hour rating. If it's below 100,000 British thermal units per hour, you can use the nameplate circuit ampacity for sizing the branch circuit conductors. If it's 100,000 British thermal units per hour or higher, you must apply the 125% rule. Let's consider a couple of examples to illustrate this concept. Firstly, suppose you have a heat pump with a nameplate circuit ampacity of 20 amps and a British thermal unit per hour rating of 80,000 British thermal units per hour. Since the British thermal unit per hour rating is below 100,000 British thermal units per hour, you can size the branch circuit conductors based on the nameplate circuit ampacity of 20 amps. In this case, you would select conductors with an ampacity of at least 20 amps. Secondly, imagine you have a heat pump with a nameplate circuit ampacity of 30 amps and a British thermal unit per hour rating of 120,000 British thermal units per hour. Since the British thermal unit per hour rating is above 100,000 British thermal units per hour, you must apply the 125% rule. To calculate the required branch circuit ampacity, multiply the nameplate circuit ampacity of 30 amps by 1.25, which equals 37.5 amps. In this case, you would select conductors with an ampacity of at least 37.5 amps. In addition to sizing the branch circuit conductors, it's also important to select the appropriate overcurrent protection device. As mentioned earlier, the nameplate will specify the maximum overcurrent protective device size. You should never exceed this rating, as it could damage the equipment or create a safety hazard. When selecting the overcurrent protection device, it's generally recommended to choose a standard size that is closest to, but not exceeding, the maximum overcurrent protective device rating. For example, if the nameplate specifies a maximum overcurrent protective device size of 25 amps, you would typically select the 25 amp circuit breaker or fuse. However, if the nameplate specifies a maximum overcurrent protective device size of 27 amps, you would typically select a 25 amp circuit breaker or fuse, as 27 amp breakers and fuses are not commonly available. It's important to consult the NEC for specific requirements and guidelines regarding overcurrent protection. The NEC provides detailed information on selecting and installing overcurrent protection devices for various types of equipment. In summary, when sizing branch circuits for heat pumps, you need to consider the nameplate information, the 125% rule, and the exception for heat pumps rated at less than 100,000 British thermal units per hour. Firstly, check the unit's nameplate for the nameplate circuit ampacity and the British thermal unit per hour rating. Secondly, if the British thermal unit per hour rating is below 100,000 British thermal units per hour, you can size the branch circuit conductors based on the nameplate circuit ampacity. Thirdly, if the British thermal unit per hour rating is 100,000 British thermal units per hour or higher, you must apply the 125% rule. Fourthly, select the appropriate overcurrent protection device based on the nameplate information and the NEC requirements. By following these steps, you can ensure that the branch circuit for your heat pump is properly sized and protected, providing safe and reliable operation. Remember to always consult the latest edition of the NEC and any applicable local codes for specific requirements and guidelines. Electrical codes and regulations can vary depending on your location, so it's essential to stay informed and comply with all applicable rules. Furthermore, it's always recommended to consult with a qualified electrician or electrical engineer for assistance with electrical installations and calculations. These professionals have the knowledge and experience to ensure that your electrical systems are safe, efficient, and code compliant. They can also help you select the appropriate equipment or materials for your specific application. In addition to the NEC requirements, there may be other factors to consider when sizing branch circuits for heat pumps. For example, the length of the conductor run can affect the voltage drop, which can impact the performance of the equipment. If the conductor run is too long, the voltage at the heat pump may be too low, causing it to operate inefficiently or even fail. To minimize voltage drop, it's important to select conductors with an appropriate size for the length of the run. The NEC provides tables and formulas for calculating voltage drop, which can help you determine the correct conductor size. Another factor to consider is the ambient temperature. The ampacity of a conductor is affected by the ambient temperature, with higher temperatures reducing the ampacity. If the conductors are installed in a hot environment, such as an attic or a conduit exposed to direct sunlight, it may be necessary to increase the conductor size to compensate for the reduced ampacity. The NEC provides ampacity correction factors for various ambient temperatures, which can help you determine the appropriate conductor size. Furthermore, it's important to ensure that all electrical connections are properly made and tightened. Loose or corroded connections can create resistance, which can generate heat and potentially lead to a fire. All connections should be made using approved connectors and tools, and they should be inspected regularly to ensure that they are in good condition. Regular maintenance and inspections are essential for ensuring the safe and reliable operation of electrical systems. It's recommended to have your electrical systems inspected by a qualified electrician on a regular basis to identify and address any potential problems before they become serious. In addition to the technical aspects of sizing branch circuits for heat pumps, it's also important to consider the overall energy efficiency of the system. Heat pumps are generally more energy efficient than traditional heating and cooling systems, but their performance can be affected by various factors such as the size of the unit, the insulation of the building, and the climate. To maximize the energy efficiency of your heat pump system, it's important to select a unit that is appropriately sized for your building and climate. You should also ensure that your building is properly insulated to minimize heat loss in the winter and heat gain in the summer. Additionally, regular maintenance, such as cleaning the coils and filters, can help to improve the efficiency of the unit. Energy-efficient heat pumps can save you money on your energy bills and reduce your carbon footprint. When selecting a heat pump, look for units with high energy efficiency ratings, such as the Seasonal Energy Efficiency Ratio, or SEER, for cooling, and the Heating Season Performance Factor, or HSPF, for heating. These ratings indicate the relative efficiency of the unit, with high numbers indicating greater efficiency. You can also look for the Energy Star label, which identifies products that meet certain energy efficiency criteria. In conclusion, sizing branch circuits for heat pumps requires careful consideration of the NEC requirements, the nameplate information, and various other factors. By following the guidelines outlined in this discussion and consulting with qualified professionals, you can ensure that your heat pump system is safe, efficient, and code compliant. Always prioritize safety when working with electricity, and never attempt any electrical work that you are not qualified to perform. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others. If you're unsure about any aspect of electrical work, it's always best to consult with a qualified electrician. Remember to stay informed about the latest electrical codes and regulations, as they can change over time. Electrical codes are designed to protect people and property from electrical hazards, and it's important to comply with them to ensure the safety of your electrical systems. By following these guidelines and staying informed about electrical safety, you can help to create a safe and efficient electrical environment. Furthermore, consider the advancements in heat pump technology. Modern heat pumps incorporate features such as variable speed compressors and advanced controls, which can further enhance their energy efficiency and performance. These advanced features allow the heat pump to adjust its output to match the heating or cooling demand, resulting in more consistent temperatures and lower energy consumption. When selecting a heat pump, consider these advanced features and choose a unit that is well suited to your specific needs and preferences. Also, be mindful of the environmental impact of refrigerants. Heat pumps use refrigerants to transfer heat, and some refrigerants have a high global warming potential. Newer heat pumps often use more environmentally friendly refrigerants with lower global warming potentials. When selecting a heat pump, consider the type of refrigerant it uses and choose a unit that minimizes its impact on the environment. Proper installation is crucial for the performance and longevity of a heat pump. Ensure that the unit is installed by a qualified technician who is familiar with the specific requirements of the heat pump model. Proper installation includes correctly sizing the unit, properly connecting the ductwork, and ensuring that the refrigerant charge is correct. A poorly installed heat pump can operate inefficiently, experience premature failure, and even pose a safety hazard. Regular maintenance is also essential for the long-term performance of a heat pump. Schedule regular maintenance checks with a qualified technician to ensure that the unit is operating properly. Maintenance checks typically include cleaning the coils, inspecting the refrigerant charge, and checking the electrical connections. Regular maintenance can help to prevent problems, extend the life of the unit, and maintain its energy efficiency. Integrating smart home technology with your heat pump can provide additional benefits. Smart thermostats can learn your heating and cooling preferences and adjust the temperature automatically, optimizing energy consumption. You can also control your heat pump remotely using a smartphone or tablet, allowing you to adjust the temperature even when you are away from home. Smart home integration could provide greater comfort, convenience, and energy savings. Consider the life cycle cost of a heat pump when making your purchase decision. While the initial cost of a heat pump may be higher than that of a traditional heating and cooling system, the long-term energy savings can offset the initial cost. Factor in the cost of installation, maintenance, and energy consumption over the lifespan of the unit to determine the true cost of ownership. Also, investigate available rebates and incentives. Many utility companies and government agencies offer rebates and incentives for the purchase of energy-efficient heat pumps. These rebates and incentives can help to reduce the initial cost of the unit and make it more affordable. Check with your local utility company and government agencies to see what rebates and incentives are available in your area. Furthermore, consider the noise level of the heat pump. Some heat pumps can be quite noisy, which can be a nuisance, especially if the unit is located near a bedroom or living area. Look for heat pumps with low noise ratings to minimize the impact on your comfort. The noise level of a heat pump is typically measured in decibels, with low decibel ratings indicating quieter operation. Finally, remember to consult with a qualified professional for personalized advice and guidance. A qualified HVAC contractor can assess your specific needs and recommend the best heat pump solution for your home. They can also provide expert installation and maintenance services to ensure that your heat pump operates safely and efficiently for many years to come. A professional can help you navigate the complexities of heat pump technology and make informed decisions that will benefit you in the long run.